Hello and welcome to Lesson 2 of our Algebra 1 Unit 1 Concept 10. Today, scholars will solve complex systems of equations using substitutions, what we used last time. Except this time we're going to have a little bit more complex systems. So if you remember last time, every time we looked at a system, you had x or y solved for. But what if we do not have x or y isolated in either of our two equations? So you'll notice in these two equations, neither one has x or y isolated. So what do we do? What do we do for those? Well, that's real simple, actually. We can actually isolate y or x in one of them. So I'm going to choose, just because I see this y here that doesn't have a coefficient, so I'm going to choose in that equation to isolate our y. So I'm going to bring that over here. Negative 5x plus y equals negative 2. In order to isolate y, I'm going to add 5x to both sides. So I have negative 5x plus 5x plus y equals negative 2, plus 5x. That gives me y equals negative 2 plus 5x. So now I have this equation with y isolated. So now I'm going to look at the other equation, and I'm going to put my value for y into that other equation. Choose a different color here. So now I have negative 3x plus 6 times y equals negative 12. Well, I said y equals negative 2 plus 5x. So now I'm going to use my distributive property. I'm going to do, so I get negative 3x minus 12 plus 30x equals negative 12. So I'm going to combine some like terms. When I do that, I get negative 3x and positive 30 gives me 27x minus 12 equals negative 12. Next thing we do is I'm going to, let me put that on here. That was my CLT. This was distributive property. Okay, so the next thing we do is I'm going to add 12 to both sides. That gives me 27x equals 0. That was adding 12 to both sides. So then when I divide by 27, I get x equals 0. Well, that is a possibility. We can have a point where x equals 0. That just means that we're going to end up on our y-axis, which is fine. So now that I have my x value, I'm going to take that and I'm going to put it back into my original equation up here. So to find my y value, I'm going to use that equation. I can put x equals 0. So I have negative 5 times 0 plus y equals negative 2. Well, negative 5 times 0 just go away, so I have y equals negative 2. So now I have an x value, I have a y value. I'm going to double check this real quick. I'm going to put it into this second equation again and just make sure that I did everything right, because I don't want at the end of this to suddenly realize that I did something wrong. Okay? So let's do this. I have, choose the right color here. I have negative, okay. Back to being a pen. Negative 3 times x, which is 0, plus 6 times y, which is negative 2, equals negative 12. Negative 3 times 0 is 0, plus 6 times negative 2 is negative 12, equals negative 12. Well, yes, negative 12 does equal negative 12. That means my answer is my x value, 0, comma, my y value, which is -2. Okay? So let's look at another example. Once again, I do not have anything that is already isolated, but I do have this wonderful x that's basically by itself. It doesn't have a coefficient. So I'm going to redo that one and say x plus 3y equals 1. I'm going to subtract the 3y from both sides. I get x equals 1 minus 3y. Then remember, I'm using my other equation that I didn't already use. Now I'm going to come over here. I've got -3 times x, and this is going to be my x value right here. 1 minus 3y minus 3y equals -15. Remember, I'm just copying this equation by replacing the x with 1 minus 3y. Next step we do is my distributive property. So I have -3 plus 9y minus 3y equals -15. I'm going to combine my like terms. So I have -3 plus 6y equals -15. I'm going to add 3 to both sides. So I get 6y equals -12. So y is -2. So there's my value for y. Go back up here, I have x plus 3 times y, which I said was -2, equals 1. X plus -6 equals 1. Okay, add 6 to both sides, so x equals 7. So my ordered pair here is 7, -2, because no matter what, it doesn't matter what order I find them in, I have to list x, then y. Let's do another example. Remember, I know I'm going quick, but you guys can always pause your video if you need a little bit more time on these. So here I have the y by itself. I'm going to take that equation, and I'm going to rewrite it so that y is completely isolated. So I have 5x plus y equals -13. I'm going to subtract the 5x, so I have y equals -13 minus 5x. That's what I'm using into my other equation to start solving this. So I have 6x plus 6 times y, which I said was -13 minus 5x, equals -6. We use my distributive property. So I get 6x minus 78 is 6 times 13 minus 30x equals -6. Combine like terms, -78 minus 24x equals -6. I'm going to add 78 to both sides. I get -24x equals, when I add 78 to this, I get 72. And I'm going to divide both sides by -24, so x gives me, instead of being negative, it's -3. So I have my x value. I still need to find y. We come back here to this beginning one. So I have 5 times -3 plus y equals -13. So I have -15 plus y equals -13. I'm going to add 15 to both sides. I get y equals 2. So my final solution for this one is -3, 2. And we're going to do one final problem just so that you make your set. So if you notice that this one is just a little bit different, because when I do this one, all of my variables have coefficients. So I'm going to go for the one that looks like it will be the least messy. So I'm going to choose this 2x to isolate, to get my x isolated, okay? So I have 2x minus 7y equals negative 17. So first I want to move my y over, so I'm going to add 7y to both sides. So I have 2x equals, and just because I like to do this order, 7y minus 17. Then I have to divide everything by 2. So I'll have x equals, and remember, you can do fractions or you can do decimals. I'm just going to do fractions. 7 over 2y minus 17 over 2. That's just easier for me. If you want, you could also write it as x equals 3.5y minus 8.5. Either of those is fine, okay? So that's just my first step. I've got my x isolated. Now I'm going to put that value for x into here. So I have, put it over here to the right, negative 5 times my x value. We'll use the decimals. I think you guys like this a little bit. 3.5y minus 8.5 minus 8y. I'm just going to go up a little bit here because I did not leave myself very much space, equals 17. Yeah, my handwriting speed can be very bad on this one. So, when I do my distributive property, I'm going to end up with, let me change my color so it's very easy to see this. I'm going to end up with negative 15 plus 17.5y plus 42.5 minus 8y, and that equals, again, 17. Going to combine some like terms. Negative 17.5y and negative 8y are going to give me negative 25.5y plus 42.5 equals 17. Going to subtract 42.5 from both sides. So I get negative 25.5y equals 17 minus 42.5, which is 25.5, negative 25.5. So when I divide, I get y equals 1. All that work, and I got a nice round number. So I have y equals 1. I'm going to put that back into this original equation. So now I have 2x minus 7 times 1 equals negative 17. So 2x minus 7 equals negative 17. I'm going to add 7 to both sides. 2x equals negative 10. So x equals negative 5, which is my ordered pair, which is always x then y, is negative 5, 1. Okay, good luck doing your assignments.